So good morning everyone, welcome back to our video. This is we're going to explore more about how we can use the Java programming, basic syntax, how to get user input as well as display number, using condition as well as the for loop. In the previous video, we explored on how to use for loops. This is a basic syntax. And you can also add some more conflict way, right? For example, as user input to some number from range 1 to the user input. Or you can allow your program to run again and again, as you can see in the previous video. We run many times, that is possible. Okay. So in this video, we're going to create a program in order to solve the quadratic equations a squared plus bx plus c equals 0. Okay. So we will create a new class test in here. Okay. If you don't see where the structure is, go to the window, show you and Project Explorer. Okay. So let's say I create a new class here inside this package test. So I create a class test3. Okay. So let's say we take this main in order to create this auto generate. Okay. So I don't need this anymore. Press this. So this is the program. So we're going to get some user input. I drop from the previous run to clear this. So we get the user input from A, B, and C here. For example, let's say the program is we say some things. Programs to find roots of equation. Okay, quadratic equations. Okay. Equation in the form of ah squared, so I put square with this symbol, plus bx plus c equals 0. Okay, you can put whatever message it is to be. So I run this. Okay, our program will do something in order to find the root of the equation where a, b, and c are representing the coefficient of this formula, and we need those input from user. Okay. So we create certain variable. Okay. Let's say I put this at integer number a, b, and c. We do a scanner, scan, and then control space to get the suggestion list. Let's see new scanner. Okay. This is to get the scanner objects. So next I can say as a equal to sc dot next int to get the integer number. We do some also display a message here, enter a, right, into a into b, which is representing the coefficient of a formula. Okay. So repeat this a few times for b and c. Do it complete. Okay, this is for b variable, okay, and this is for c variable. Okay, next we get the coefficient already. The step in order to find the root, we first need to compute what we call the delta, right? Delta. Okay, so we create a data variable. Okay, let's say input these are floatable. Oh, sorry, delta. And then do something like say delta equal to b squared. Okay, b times b minus 4 times a times c. Okay, so we got b squared minus 4ac. You cannot write just only for ac here. It does not work in programming. If it is multiply, make sure you input star symbol here. So we get the flow already. Next is to check, double check whether this variable is 0, so that we compute with a certain piece of formula whether it is greater than 0 or less than 0. Let's say I test with this with 0 or greater than 0 first. Let's see. I have a block here, open, closed. And if when delta is 0, what happened? What we should do? Okay. And if when delta less than 0, what we should do? Okay. This is the basic syntax of condition. When this condition is true, code inside this if it run, this will skip automatically. But if this condition is not right, we check the following condition, And then if it is true, this is run code inside this condition. The rest skip, so on and so forth. It continues to check the other condition. Only if the current condition is checking is not right, it's not true, no? It is false, you continue to check the other. So let's say we test with data greater than 0. So we will try with the what we call the root of the equation x1, x2. So we know the formula x1 and x2 already. So let's say I create some variable in here, 1 and x2. x1, what is the formula? We do something minus b plus square root of delta over 2a, right? So make sure that you do the grouping symbol with parentheses in case to avoid some error in mathematics. Sometimes you divide first and then you multiply later, or you divide the whole group altogether. So let's say for this, minus b plus delta, okay, square root of delta can be accessed from math here. You can type math and then control space. Dot, there will be available function and constant, for example pi, absolutes, and other functions. For example, in this case, square root sqrt. As you can see here, it needs a double. So if you pass it as a float, see what happens. I pass a variable from data, it is what defined as the float here. So you can see the line here saying something called type mismatch cannot convert from double to float. It means that this function library needs an input as floating double number. Float and double, actually they both used for storing the floating number, but double they store more number than float. They are more domain. So to fix this, just change this from float to double. Okay. Also change this float to double. Okay. This would fix the problem. So this is for x1. For x2, we use the same formula, right? Based on our mathematic formula. Okay. Well, b minus b minus math square root of delta over 2a. And then you can do the message display. Okay. Put something, let's say 2 roots. Okay, we found 2 roots. Okay, found 2 roots. What are they? Okay, x1, what is the x1 value plus x1? Okay, and then we do another operation, 2 equal to plus x2. We do combination between variable and text, so that we can say found roots x1 equals something and x2 equals something. Okay, we pass the value x1 into this certain space. So in case of delta equals 0, it means that x1 and x2 are the same. So say down, you can use only one, is fine. Okay. So the rule is that delta is already 0. It means that we have only minus b over 2 times a, right? Okay. This is the rule because this part is always 0. Square root of 0 is 0. So we got only this part. Then you can display the message. Almost finished this. Let's see, found double root. Okay. Double roots. Okay. What are they? x1 and they are the same. The value is the x1 x2 you can paste into. Okay. However, for the data less than 0, what you should do, you can just only display complex number only without finding the real data x1 x2, which depend on the variable I, right? So basically we know I square is equal to -1 in complex number. Okay. So for the rule in here, you can do something. Let's say add the box here in order to explain you. Okay. So suppose that as you can see in the previous formula, that we apply certain rule, right? Do something blah blah here in case it's 0. So what happens when data is less than 0? It makes this formula error, right? Because under square root cannot be negative number. That's why you can do something what we call e square which is representing as -1, right? We have this imagination part. So what we can do in here, we convert this, right? So this could be representing as certain things. Let's say I divide this into this formula, P plus Q I. Okay, so what P represent is B over 2A, right? Okay. While Q is equal to this part, right? Okay, this part. I will break this down into further. Okay. So in here, because this part equivalent to I, it means that this is I square. It's inside, so it means this could be converted to minus. Okay, because this when we merge this with this part, it will become as math square root of delta on d, right? Because -1 here we add, we can get this I. Okay, that's the reason. Okay, so we're back to our code and we create some variable. Let's say this is P and Q, where P is equal to minus B over 2 times A. Okay, while Q is equal to math square root, because delta is a negative number, so that's why we add minus here. This is very important to make this into positive so that it can stand under the square root. Okay, so the formula is divided by 2a. Okay, so this we can calculate, right? This will give you a floating number. We can calculate for you. So as the result, you can display. Okay, found something what's called complex roots. What are they? Okay, so add another line here. H1. It is in terms of P plus Qi and P minus Qi, right? This is a number together with I. Okay, symbol I. Okay, so do something plus A plus P. Okay, and then if you have do something and then Qi, right? Then we can pass the variable, the number is Q, and then plus I. Okay. Because I here it is static. Okay, I want to get in the form of on equal to number plus number and then I. Okay, P and Q here are computed as number. Okay. Same way to either, we just change the symbol from plus to minus here. So either here, this is to minus sign. Okay, that would work, right? P variable replace in here, Q place in here, and then we get the structure. Okay, let's run this. So we got the first input. Let's say I have two, whatever you want here. So we found the root, right? Found two root in this case. While A equal 2, B is 4, C minus 1. We got this number. Okay. You can also check it online whether this program is correct by using quadratic calculator and then input A, B, and C and verify this information. Okay. Just search in Google quadratic equation calculator. Click a link, input A and B, and then compare your result. Let's say I try another case. Let's say A is 1, B is 2, C is 1. So it means that B squared minus 4 times A times C, we got delta 0. So we got double root. That is right. So a little bit mistake in here. You should add equal sign, otherwise we don't get the right output in here. It's strange. Okay, so I put minus in here, equal sign in here. Run it one more time. 1, 2, 1. We got double root. Okay, that's right. So let's say in case we run with the another number which compute the data into negative number. Okay. Let's say I put 4 and B I put 3, while C we get 2, for example. So 9 minus 32, we got negative number, right? 4 times A times C. So this we count the complex root. As we mentioned, we do something the P, and then this is the Q part. Okay, there's something wrong here. As you can see, why this is 0? Okay, why 0? Let's study the case. P equal to dot minus B over 2A. So this one 3 over 8 นะ 3 over 8, it should be 0 point something นะ okay. The reason is behind this division number. B is integer number, A is also integer number, so it means that integer over integer, we got only integer number. That's the rule in programming. So what we can do, you can casting this data. Let's say we cast it into double. Okay, this is called casting. Casting, convert from integer to floating number, because this division can contain division, but we store as integer over integer only. So we convert the this part into floating number and then divide. So we should get the floating number. Okay, let's see. As you can see here, we got the floating number. Okay. So this is one solution that solved by casting. Or another solution, you don't do this, just create your variable. So I put this, I remove this part. Just create variable as, let's say, float or double is fine. Let's say put this as float, and this we should change. This is float, so this one should also be changed into next float. Otherwise, you get only integer number. So let's say run it again. We input 4, 3, 2. Just we get the same thing without casting anymore. Because B here is float. This is overfloat. Float over float. We got float. Okay. So the rule for this is that very simple. We have the rule of division. Okay. If it is integer over integer, the result we get will be integer. If it is integer over float, we will get float, because the division, the operation contain float. Okay. If float over integer, okay, we still get the float number in programming. Float over float, yeah, exactly float. Okay. So remember, at least one of the operands, either this operand or this operand, they contain float, we will get the floating point for the result of division. Okay. This is thing to remember. So I think that's it for this video. Thank you for your attention.